Okay, so we're on day 2 of how to graph systems of equations. Today we actually have to do our own graphs. So really this is going to be more of an example of the limitations of graphing systems of equations. Okay, let's get into it, and then we'll see what I mean by limitations. So we have 2 equations here. If I want to graph them, I see one of them is already in slope-intercept form. Good, I'm going to leave it like that. But if I take this second equation, let's just rewrite over here, 2y is 10x minus 36. If I want this to be in slope-intercept form, I would need to divide everything by 2. So that gives us y equals 5x minus 18. Okay, and now we have 2 equations that we can graph. So we come over to our graph here and we see, okay, I've got one with the intercept at 6, which, oh, that's not on the graph, but that's okay. I can go up one more. -3 is my slope, so I go 1, 2, 3 down, 1 over, 1, 2, 3 down, 1 over, 1, 2, 3 down, 1 over, and I can graph one. It's not too bad. I graphed one, good for me. But then I've got 5x minus 18, and it's like, oh, yikes. So my intercept is -18, so I would have to go, and suddenly to get to -18, I'm in the next graph, and that's not going to work. Okay, so what can we do with this? Well, we can use a better graphing tool. So what we're going to do for today, don't tell anyone we're doing this. We're going to go to our Desmos calculator. Make sure you're on the testing/Texas/graphing version, because later on, when you have to do a test, that'll be the type of calculator you use. Okay, so I'm going to put in, if I can find my mouse, I'm going to put in my 2 equations. So my first one was y equals -3x plus 6. Yeah, that looks like the one I graphed. And my second equation was y equals 5x minus 18. There we go. Okay. So now if I look at my graph here, I can see that they meet at a point at 3, -3. Okay, 3, -3. Don't forget that. So I'm going to come over here and I'm going to plot 3, -3. What was this? This was blue. Well, that's good because I already had a point there. I can finish my graph just for giggles. So my slope was +5. So 1, 2, 3, 4, 5 over 1. Yep, this is going to be perfect. Okay, so our solution for this one is right here. 3, -3. Remember, just like yesterday, we can check this. If we take that and substitute it into our equation, so does -3 equal 5 times 3 minus 18? Well, that's 15 minus 18, which is -3. -3 definitely equals -3. That checks out. We do the same thing for our first equation. So -3, does that equal -3 times +3 plus 6? So this would be -9. -9 plus 6 is -3. This checks out as well. So this is the correct answer. Okay. So one of the limitations of graphing systems of equations is even if you can get it into a nice slope-intercept form, if that intercept is not on a graph, or if it won't fit on the graph you have, can't really do it effectively. I mean, we could do it once we knew the answer, but once we know the answer, making the graph, it doesn't help us. Okay? Now, if you had a whole piece of graph paper, you could get to -18, but now you're taking a whole piece of graph paper just to make one line, and that seems inefficient. So that's one problem. So let's look at number 2. Extend the page a little bit. So this one, our top equation is all set. So you can leave it just like that. Our second one is 3y equals 5x plus 5. So to get y by itself, we would have to divide everything by 3. And so that's going to give us y equals 5/3 x plus 5/3. So same thing with our green, our top equation there, -9 is not on my graph. Bummer. But my blue one, +5/3, that's 1 2/3. That's up here. But the problem now is, because it's not on the grid lines, it doesn't really make a very good graph, because we won't have exact numbers. We'll sort of just be guessing at it. So another limitation of graphing is if you get a y-intercept, it's a non-integer value. So what can we do? Let's go back to our calculator. There it is. Let's delete our old graphs. We can start over. So we had y equals -x minus 9. And then we had y equals 5/3. And then make sure you press the right arrow, because if you put your x in the denominator, you get a totally different graph, which looks cool, but it's not what we want. 5/3 x plus 5/3 again. And we will see, there it is. Where do they meet? Right here, -4, -5. Okay, don't forget, -4, -5. -4, -5. So let's plot our point there. So that should be our answer. Let's write it out. So we're going to check it just to be sure. What if I made a mistake writing my equations? Let's graph it just for fun. So our green equation on top, -x. So I can't go down and to the right, so I'm going to go up and to the left. Yeah, see, exactly. Look how much of that line fits on the graph they gave us. Come on. What do they expect from us? Our blue one, +5/3. I'm going to count up. 5/3. We can do that again. 1, 2, 3. That's not perfect, but closer. And we can see, oh, there it is, across that 5/3. Success. We can check this one though, just to be sure. So our top one, top equation here, -5. Does that equal -4 minus 9? Well, this is just 4 minus 9, which is -5. That checks out. Okay. And then our bottom equation, I don't want to put it into this one that I worked out. I want to put it into the original equation. So I'm going to say 3 times -5. Does that equal 5 times -4 plus 5? So this would be -15 on the left. This would be -20 plus 5. -20 plus 5 is -15 equals -15. This checks out. Since it works for both equations, this is a good answer. There it is. All right, so there's limitation number 2. If we've got a y-intercept non-integer value, it becomes very difficult to graph manually. There's one more limitation we won't get into because it won't come up today, to give you a hint. If one of our answers was a non-integer value, like say somehow we ended up, what if we graphed it? We graphed it perfectly, we did it all by hand, and here's our answer right in the middle of the box. Do we know what the answer is? Sort of. We can estimate, but we won't be able to get an exact number if it doesn't fall on the grid lines. Okay? So graphing, it sort of works. In a perfect world, if you could graph using either slope-intercept form or standard form, if the intercepts gave you nice integer values, then graphing works just fine. The problem is, a lot of the time, that's not what you're going to get. So graphing is nice, and if they gave you better problems, which these ones, they're not. These are kind of ugly problems. I don't know if they were really thinking through that you actually had to graph these. So graphing is one way to solve systems of equations, but I definitely would not recommend it over substitution and elimination, which we will get to later on. All right, well, good luck with these. Use your calculator to graph stuff. Just make sure everything is in slope-intercept form, because that's how it'll be on the test. Okay, bye.